The X13 was introduced in 2006, and it is a completely new application of ECM technology. It's predominantly used in air handlers and package systems. However, the market for using X13 in furnaces is growing rapidly. If you compare the X13 to the variable speed, the motor that we started building some 20 years ago, you will see a lot of similarities. They're both ECM motors. They're both brushless DC motors with a permanent magnet rotor. However, the variable speed is a premium product, whereas the X13 is what we call a standard product, a new tier, if you will. Both motors are also 80% efficient. One other difference is on variable speed motors, you can replace the motor separately from the control, whereas in the X13, the control is actually integrated up into the motor shell. And on variable speed motors, the manufacturer can actually program the exact amount of airflow they want for heating and cooling or even dehumidification functions, whereas in X13, you just have 5 speeds or 5 programmable torque taps. And finally, variable speed is made constant airflow, where once you select an airflow point, the motor will make that point when static pressure in the system changes. On X13, we have something called constant torque, which we will explain here. The X13 is built in 1/3, 1/2, 3/4, and 1 horsepower models. It's also built in 115 volts, 230 volts, and new 460 volt applications. The X13 takes advantage of our latest single board technology, where the board is also fully encapsulated to protect it from water damage. Like all ECM motors, the X13 is speed limited, has ball bearings and surge protection, and what we call soft start, soft stop, meaning we turn on the motor with a little bit of power and then increase power to bring the motor up to speed and then turn it off the same way. On the X13, we also have something special called a braking function. When the manufacturer's control board turns off the X13 motor, we will actually brake the motor and bring it to a stop much quicker than a PSC motor or even our variable speed motor. So if you see that happen, don't think that there's something wrong with it. That's perfectly normal. In comparing the X13 to the PSC motors, we see that the X13 is just as easy to set up and troubleshoot. It's a one-piece motor, and it basically has 5 speeds or outputs like a PSC motor. However, the major differences are on a PSC motor, if you have 5 speeds, those are 5 fixed speeds. With the X13, the manufacturer of the HVAC appliance can program each one of these taps for whatever output they want. So the airflow can be actually more specific and more accurate in that system. We also know that PSC motors operate at roughly 60% motor efficiency, whereas ECM motors operate at roughly 80% motor efficiency. So we have an increase in electrical efficiency going from PSC to X13. The X13 is built with constant torque, which we'll be explaining here in a few seconds, and it also, because it's an ECM motor, does not require a capacitor. So let's look at that explanation of what constant torque is. What you're seeing right now is a chart that shows airflow in CFM on the left-hand side and static pressure on the bottom of the chart. And when I say static pressure, what I really mean is the total external static pressure of the system. All of the ductwork, the filters, and the evaporator coil that the blower has to work against to move air. Looking at the chart on the right, we see a PSC motor. Looking at the chart on the left, we see an X13 motor. And without giving you any more information or even talking about the numbers, we can easily see that as static pressure goes up, on the PSC motor, airflow falls off very quickly. On the X13 motor, airflow still falls off. It still goes down, but it doesn't go down as sharply. So let's pull in some numbers here. On the PSC motor here, we see that at 0.5 external static pressure, which by the way is where manufacturers rate most of their systems to operate at, the PSC motor is moving 1200 CFM. If we raise that static pressure to 0.8, we see that the PSC motor dropped down to moving only 1000 CFM. That is a very severe loss in airflow when static pressure goes up due to filters getting dirty, registers and supplies being closed, and that could easily cause our furnace to overheat or our air conditioning coil to freeze. If we look over at the X13 slide, we see that at 0.5 external static pressure, the X13 is making 1,275 CFM. And when we go up to 0.8, the X13 only falls to 1,175 CFM. So it only loses 100 CFM, whereas the PSC motor lost 200 CFM. This could easily make the difference between the system overheating or not, or the evaporator coil freezing or not. It's a more moderate loss in airflow due to the constant torque technology. So now that you understand how airflow is affected by PSC and X13 motors, and how an X13 can actually do better at higher static pressure than a PSC motor, let me tell you a little bit about how the motor actually does that. X13 motors are programmed with something called constant torque. A torque value is put into each one of these taps, and when those taps are energized, the motor will run at that torque value. When you put this motor in a blower section in a system and start moving air, the load to the motor is the air that the blower wheel is moving. In a PSC motor system, if you decrease the amount of air that that wheel moves by having a dirty filter, registers that are closed, or undersized ductwork, that PSC motor is literally going to draw less power and simply move less air. It's not a smart motor. It doesn't have a control on it. It doesn't know how to do anything else. However, the X13, with its constant torque, has been programmed that if the load decreases, it has to draw more power to put the same amount of torque on that shaft at the lesser load, which in turn makes the blower wheel go faster and helps save some of that airflow that is being decreased by the increase in external static pressure in the system. So it's not constant airflow like in our variable speed motors. Variable speed motors are programmed to know exactly how much torque and speed is necessary to make whatever amount of airflow the manufacturer programs into that motor. It can't maintain a specific airflow point. What it can do, however, is maintain a little bit of power on that shaft when static pressure wants to unload the blower wheel and cause the whole system to simply move less air, which in turn is going to help us not trip limits as much, freeze coils as much, and maintain some of the capacity and efficiency of the system. With X13, we've increased the marketplace for high efficiency ECM motors. First, we started with the variable speed, a premium ECM product, and now we have the X13, a standard ECM product that can be applied to more HVAC systems. With constant torque, the X13 still improves airflow, and with proven ECM technology, you can be confident in the use of this product with over 20 years of use in residential and light commercial HVAC systems.